So thank you everyone for joining us this morning, and thank you to those who have been watching on YouTube. As mentioned in previous sessions, we started this coach socialization series as a way to connect coaches during this time of isolation and provide a platform for you guys to connect and continue to learn. So today we have a new topic. So we have Josh here from the Canadian Sports Centre Atlantic to talk to us about using technology to analyze our performance, which I believe is a really relevant topic right now with this generation. And there's lots of benefits to technology. And so Josh is going to be speaking to us a bit about that. As a friendly reminder, just use the chat box for any questions, and then we'll open up our microphones at the end for a discussion. So Josh, take it away. I will mute myself and you can share your screen.
Great, thank you. All right, hopefully everyone can see that. Thank you for the introduction, Kirsty. Like Kirsty mentioned, my name is Josh Gorham. I'm a performance analyst at the Canadian Sports Centre Atlantic, and today for the Coach Socialization series, I'd like to chat a little bit about using technology to analyze performance. So I just quickly looked at a few of the people who are on. Most of you probably know who I am. I know you, at least. Just so for my background, I'm a performance analyst, like I mentioned. I mainly work with Canoe Kayak Canada. Worked with them since 2013 in the performance analysis role with Mike Duvall at the center as well. And recently I started working a bit with Gymnastics Canada with Scott Wilgris, strength and conditioning coach at the Sports Centre. So we're working on a project with Gymnastics Canada looking at training load and using inertial measurement units. I'm also a PhD candidate in sports biomechanics at Dalhousie University, a part of the BIN Lab. I see my supervisors on here right now. So that's Dr. Michelle Ledouceur. And I also worked as a sports science intern with the Kansas City Royals in 2017, mainly helping out with their sports science manager. And that really gave me a good idea of what was happening in the professional world. Most of the work I've done is with amateur sport. So working with the Royals gave me an insight as to what they do in professional sports. And then finally, I worked as a performance analyst, technology specialist at the Canadian Olympic Committee last year at the Pan Am Games in Lima, Peru, and also supposed to be at the Olympics this summer. Obviously, that's postponed for a year, but that's I was supposed to be going there as well. So today, for this session, I would have two goals for the session. The first one would be helping introduce the use of technology into your coaching practice. So some of you may use technology day to day, every day maybe. If you don't, hopefully some of the stuff in this presentation can help you introduce it. Or if you do use it, just provide insight as how technology can enhance performance, maybe more than what you're using it for or in a different way. I have an outline of going over the technology basics. I have a couple of examples from Canoe Kayak and what I've done there, both in the daily training environment as well as race day. And then go into a little bit on reliability and validity. Technology, it seems like there's a new piece of technology coming out every day. So it's very important for us to ensure that that device or piece of technology is reliable and valid, because believe it or not, a lot of it isn't. I should mention too that I do sport biomechanics research, so I'll be providing this information from a biomechanics lens. There's a lot of technology that's used in mental performance as well as strength and conditioning and nutrition. You name it, any discipline really has it. So I'll be looking at it through a movement and technical or technique lens. Another thing is a lot of the examples I use today will be from very specific sports. The good thing is a lot of the stuff we chat about will be transferable to other sports as well. So even though it may not be the exact sport you're working with, chances are something can be transferred, as well as with the Own the Podium, our performance analyst group. We have a group of analysts across the country, which chances are one of them is working with your national sport organization or your sport in some capacity. So to get started, I just wanted to ask the question, what sport do you coach? Hopefully I'll be able to see that in the chat as I go through and maybe get an idea of where you guys are coming from. So if you don't mind writing that in. If you don't coach a sport, maybe the sport that you're most interested in from a technology perspective. And going through the presentation, it would be great if you could think about how you currently use technology to enhance performance in your athletes. So what pieces of equipment do you use now that will that you currently use to help your athletes? Or think of the ways that you could change the way you use technology to help your athletes. And finally, why should we be using technology? A lot of people may not necessarily think there's a need for it, but if you look at the literature and what's actually happening out in the world right now, this is a busy graph or busy slide, but there's a review paper a couple years ago, trends supporting in-field use of wearable inertial sensors in sport performance evaluation. And what this graph or these graphs show me is that there's a lot of research occurring right now in this field in technology. On the left-hand side of the screen there, you see the different journals, scientific journals that are publishing this stuff. But also you see on the right side in the bar chart, since 2008, there's been a steady increase in technology-related papers. So that means here in Canada, some of these papers may be from here, but it also means across the world, people are investing in technology to help their athletes. We really don't know where this is going to go. It may plateau at some point, but in my opinion and what I've seen, it seems like technology is just going to continue to rise. So as you'll see throughout the presentation, I'm a big fan of baseball. Obviously did some work with them. And this article right here was published in 2018. It's the next Moneyball is already happening around us in the wild west. In this message was that 2003 took on an analytics approach. Now we're going into using technology to enhance performance, maybe help an athlete that may not have been increasing their performance over time, or they may be stagnant. There's different ways now we can do that. And this graph, or this table, I should say, shows in 2018 some of the analysts that were employed by various teams. Interestingly enough, in this article, they say that this is definitely underrepresented. There's a lot more, and I would be willing to guess these values have maybe doubled or tripled since then. Just in February, I actually came across 5 positions with various major league teams. These jobs in sports science and technology-related jobs are really popping up every day. And a couple days after this, there are more. So it's just every day something new is happening. And if you're interested in this type of stuff, this book here, the MVP Machine, talks about how data is basically transforming the sport in baseball. But if you're interested in other sports, obviously you are, this may give you some insight as examples of how it can work. So a lot of you obviously are coaches. You may want to include technology in your practice, but you don't necessarily know where to get started or how to get started. So in this quick Google search, I just looked at technology analyze sport performance, a few keywords, and this is what popped up. And as you can see, there is a ton of information in this slide. It's there's various softwares, various pieces of equipment, technology, that sort of thing, a lot of feedback being given. But to me, this is really overwhelming. Even to me, I see this stuff every day, but something new is popping up. Somebody else is using a new analysis tool or a new piece of equipment, and it's just nonstop. So we really need to go back to basics here and try to think about what is sport technique and how can we look at it? How do we assess it? So in some of the research I've done, I've did some review work to try to see what other people are saying and how sport technique is assessed. And by Lees et al. In 2002, they defined Technique is the relative position and orientation of body segments as they change during the performance of a sport task to perform that task effectively. And we can look at that from multiple different ways and different pillars or topics. The three main topics, though, would be qualitative lens, a quantitative lens, and a predictive lens. So for qualitative, we can we can look at it from observational or deterministic models. From a quantitative perspective, we can look at it through performance parameters, movement variability, coordination, efficiency, that sort of thing. And then from a predictive standpoint, we can look at modeling and neural networks, and that's really taken off in the last few years with all the various computer science technology and methods that are coming out. But today, what I really want to focus on is performance parameters. There's some evidence that suggests that recently movement variability is more important than simple discrete measures like performance parameters. But I think it's an easy place to start for a lot of coaches and a lot of people trying to learn the basics of their sport and how to increase performance. So if we look at performance parameters, we can also talk about this from a key performance indicator standpoint. This is a business term, obviously, showing some sort of indicator that increases performance. So the idea is if you can increase that indicator or variable, performance should follow. And performance parameters are really discrete biomechanical variables related to successful performance. So in this figure right here, you see Usain Bolt crossing the finish line in Rio. A couple probably important performance parameters for him would be obviously time. He wants to go as fast as possible, but then we can look at the deterministic model and what makes up time. So distance and average speed. These deterministic models really became popular back in 1983 in the 80s from James HighE. I'm a real sport biomechanics person that we look up to and really started a lot of this information off. In this deterministic model, we can really break down performance by looking at one variable and in the next level, so say we start at average speed, the next level down are the two variables or multiple variables that make up that. And in this case, it would be stride length and stride frequency. So if you're really struggling to look at a performance and see how you can help an athlete, this could be a good place to start. Look at a performance metric that actually matters and then break it down into a deterministic model. So I'll give a couple performance parameter examples. As I said, a big baseball fan. If we look at Mike Moustakas on the left and George Springer on the right, if you look at their data, their analytics, we see that they have the exact same average exit velocity. So when they hit the ball over the 2018 season, their average exit velocity was 88.5 miles per hour. But as a coach, do we really think that their technique is the same throughout the movement? Well, we can start by looking at some of the technology, using that information to better understand their technique. So in this graph here, what we see is the efficient kinematic sequence. So each one of those waveforms is a different limb segment or body part, and that is during a swing. So when they swing the bat, maybe we would collect information on their trunk, their upper arm, their forearm, and then maybe their hand or the bat. And that can give information as to how the sequence works so that we can increase their exit velocity. So in that book I mentioned before with the MVP machine, they talk a lot about that and how technology has really changed how baseball coaches actually coach. So again, if we step back here for a second, we always want to start simple. In your sport, what are the most important performance parameters? In this example here, again, baseball, we look at this graph. On the y-axis, we see the number of strikeouts. On the x-axis, we see the average fastball velocity. So there's a bit of a trend here that as fastball velocity increases, so do the number of strikeouts. So maybe that is performance parameter that you would want to collect. So as a coach, how would we measure them? We can do what they've been doing for many years and just use radar gun, during a game. Obviously, that's one of the ways you would do it, especially locally. You can write the information down on a pen and paper or clipboard. Or we can start thinking about how technology can help. And this piece of equipment right here is called the Rapsodo device. And that gives information on a ball pitched and a ball hit. It gives information about spin direction, spin efficiency, obviously velocity, that sort of thing. So if we're looking at fastball velocity or how much it breaks or moves, that would be a good piece of technology to use. And the most important part here is it's pretty simple. Obviously, you can't collect it in a game, but you can in practice. And why I say make it simple is because this type of setup is a bit advanced. If you try to do this or try to do this daily or whatnot, it becomes very complicated. It upsets the workout, and it can impact the performance negatively. So we want to make things so simple that the athletes don't really know what's happening. So some of the types of technologies that we can look at would be wearable sensors. As you see up here in the graph, up in the figure around the yellow circle here, there's a small inertial measurement unit in the back of this vest of the soccer player. What that measures is distance from the GPS, global positioning system, measures the accelerations, decelerations, distance that athlete may have ran throughout a day. And this is information that was once only collected in maybe the most expensive, for the most expensive or teams. However, this information can start being collected by as much as like $100. Now you can buy a sensor that would give all this information. So it's really changed the landscape. Types of technology, again, would be video cameras. A lot of you probably use that daily. Obviously, there's pros and cons to this. One of the things you need to look out for here is for faster sports or sports that have a lot of speed, you want to have higher sampling rates to ensure you're not missing data. And then finally, we have our video and data analysis technologies or softwares. I think this is a great time to investigate using some sort of software. Obviously, we're in isolation. You may have a little bit of time on your hands. You may have less time on your hands. I'm not sure. But you don't have to know everything about these softwares. You can pick one and use it. Obviously, they do a little bit different things for each one. And I would be happy to discuss with you what the best type of software would be for you maybe after the presentation. So yeah, very important. What tools are right for you? So again, these aren't going to be helpful for everyone. So I'll give a quick example regarding the daily training environment. We see here Scott Wilgris with a Lactate Pro. He measures lactate on the athletes. That's a certain type of technology. On the right, we see Kayla Miller. She's a master's student in the lab with Michelle Leducer. We're collecting EMG, electromyography, as well as sensor data, kinematic data on an athlete. And this is for more research purposes. This is a more advanced setup. But we can use technology in other ways within, say, Canoe Kayak. In this case, we want to wonder how can technology help. If you look at this picture here, we see 5 athletes finishing a race within milliseconds. How can we make that Canadian athlete that's in lane number 5 be at the front of this, or the most right of this picture? How can we make them win the race? So you can't just measure everything with a stopwatch anymore. There's evidence to show that hand timing produces significantly faster sprint times than electronic timing. I mean, it is pretty reliable in a sense, well, relative to this study, what they found. But we want to be as accurate as we can, because when races end like this, we can't have milliseconds missing in our day-to-day work. So how we get started, and we need to have that thing that we should measure. So if we look to the literature or even data that you've collected or you've learned over the years from your experience coaching, this paper right here, McDonnell et al., shows a deterministic model of the average kayak velocity over a race and how we can break that down into very fine details to help our athletes win. So if you look at the average kayak velocity over a race. We can break that down further into one stroke, and then we finally can break it down into the displacement per stroke and the stroke time. So that's a good place to start. And a key thing here to look at is the numbers. The numbers are the correlations between the two variables in performance. So obviously a higher correlation means that variable is related more to performance than the other variables. So we want to look at, say, stroke time. In our sport, stroke rate, the inverse of stroke time, is quite important. So to do that, we need a measurement tool. From a daily training environment perspective, all of the national team athletes have used this unit called a spin unit. It's an inertial measurement unit with an accelerometer, a gyroscope, and a global positioning system in it. The accelerometer can measure accelerations in 3 dimensions. So the x-axis, the y-axis, and the z-axis. So that could be forward, back, side to side, up and down. As well as the gyroscope can measure angular rotations. So pitch, yacht, and roll. So this is very important for a boat, as you can suspect, especially when you're looking at drag and that sort of thing. And then finally, the global positioning system. This system in this unit gives us information 10 times per second. And it gives us position data, where those athletes are at all times on the lake, how fast they're moving, and that sort of thing. So how do we measure it? We take that small unit, we put it on the stern end of the boat, just posterior to the athlete. As you can see on the left, it's about 15 centimeters from the back of the boat where the athlete sits. And then on the right, this is Mark Dion at the London Olympics, where he won a bronze. There's the spin unit in the back of him. He gets information regarding his race. So we get this information and we can bring it into a certain type of software specific for this device. Most devices have their own softwares. But what we can see here is where the athlete is, say in the real world, so where they are in the lake. You can see on the top graph there a timeline of their entire workout. This middle graph, we can see their velocity and how that changes over time, especially for that workout that we're most interested in. And in the bottom graph, we can see their stroke rate. Each one of the orange vertical lines, I know it's kind of hard, they may blur together. That's a stroke. The black line in the background there is the acceleration of the boat. So every time the boat accelerates, we detect that there's been a stroke. And then we can measure their stroke rate, which is the blue line in the background there. So that gives us information about how their stroke rate increases may increase their velocity. But we need to measure this over time. So we need to relate this data or these data to performance. And to do that, we can calculate these small metrics quite quickly, actually. It may look difficult, but after you get the hang of it, it's pretty quick. And then we can relate, say, average maximum stroke rate in a piece to the average maximum velocity. And again, there's a bit of a relationship here. Obviously, stroke rate doesn't tell the entire picture, but it at least gives us some sort of information that we can use to help our athletes. It's really important to collect this information over time. So it's good to get this information in, let's say, in a training, one training, but where this really becomes powerful is as you track it over time and you can track your athlete to see if they're getting better. It's another thing to think about is if you give them a technical cue, do you know if that technical cue is working? Well, unless you're collecting data to show that they are getting faster, it's really hard to say that specific cue actually helped my athlete. And when you're collecting this data, you can collect it, say, in an Excel sheet, or if you're working with a data management system company like Kinduct, you can put that information in there where the coaches can come in and look at their athletes from a day-to-day perspective. Athletes can go in as well. We can also use this information to dig a bit deeper. So if you want to use a cue, you may think that the athlete needs to accelerate quicker. We can determine that information hundreds of times per second, as you see in this graph right here. So what we see here is the acceleration on the y-axis, the time on the x-axis, and we can see each side of the stroke. So we can dig a bit deeper, determine how that waveform can change to give us the best performance possible. a past project of mine with Intel, we looked at providing real-time feedback to the coach and the athlete. So we can put a small inertial measurement unit, GPS, on the back of the boat. We can collect information with Microsoft Surface Pro or any tablet. We can give information in real time, say the speed or the stroke rate, the distance per stroke. We get real-time information on the bottom of the screen, as you can see, the accelerometer and gyroscope data. Now that may not be that beneficial, in real time, but it is. It can be quite useful after the fact. So that was our kind of daily training environment. Now, if we think about this as a race day performance, how can we really use technology to help our athletes win on the international level or the national level or wherever you coach? So in this case here, we looked at data back from 2016. This is just an example, but we noticed that the Ukrainian crew is maybe a crew that we want to investigate. We want to look and see how we can beat them in future races. And this is a real world example. Back in 2016, we looked at it for the under 23 championships in men's canoe in a crew boat. And what we get here is we can get information about the athletes, but we can get information about their speed, their stroke rate, and we can get this at a very high level of resolution. So every 10 meters from this race, we basically picked up information that can tell us how Ukraine races. So we want to know, we know we're racing Ukraine in the future, so we want to look at their data over time and determine how much time or the percentage of the race time they spend in a specific split. So in this case here, we see the split's broken up into 100-meter intervals, and these are two races. We see Duisburg in blue, Berchiche in orange, and we can see that they follow a pretty similar pattern right up until the last split. And I could go into that deeper, but really what that means is they spent too much energy throughout the middle portion of the race. But we looked at these from not only their finals, but their their heats and their semifinals, and we compiled enough data to show that they do pretty much the exact same thing every time they race. And we knew that a time to medal at U23 Worlds was about 3 minutes and 35 seconds for these athletes. So we go back to the technology and we try to understand what data we do have. So this is a sample report, stroke report, or race report that we would give an athlete and a coach after each practice or race. And what we see here is the rate, so the stroke rate in blue and the velocity in red. We get this information, like I said, hundreds of times per second. But from that, what we can do is we can break that information down even further into, say, how much time they took per split and what we should suggest. So from our information on Ukraine, we kind of could tell how they were going to race their race. So how can we change our race plan to maybe work and get a better result? So we can give our athletes suggested times, we can give them suggested stroke rates, and what we can do is track their progress over time. So this example here is just from one day, one morning. We gave our suggested information. They went out and raced. We calculated what their times per split were, their stroke rates actually were. And what we saw is that in this figure, we see the green is good, the orange and the red is bad. So they did a really good job up until about the 500, 600 meter mark, and then they started to slow down. So this information kind of gave us insight. Okay, we're going too fast at the start. Let's slow it down. So within the same day, we changed that race plan a little bit, and we start to see that they're getting a little bit closer to where we want them to be, and their time actually decreased as well, which is most important. And we also modeled this to an extent that we showed that if we simulated a race, we could see that Ukraine would be leading pretty much until the 700 meter mark. And that's really where Canada would pull ahead and then hopefully win the race. And this wouldn't be by a lot of margin, but it would be, we would win the race. So if we look at race day, I blocked out names just for confidentiality reasons, but what we see here is that Ukraine did win the race, but if you look at the final times, they won by a second, and we were under our time that we wanted to be of 3:35. But what's most important here is that at the 250 meter mark, exactly where we wanted to take over, we were tied. And that's exactly where we thought we would be tied. And even better is we thought we would be a little bit slower at the start of the race, which we were. So things happened in that race that eventually caused a slower ending, a slower end spurt, which made us lose a second in the last 250 meters, as you can see. But this is a positive result and shows kind of how technology can help. So what really happened with this technology, we can determine we had a conservative start. These are 3 different types of races. This is our percentage of time in the race, or in the split, sorry. We have our suggested time in dash blue. We have a race we did at team trials in yellow, and a green UT3 Worlds, where we have a corrected time of 3:41. So what really happened, we had the conservative start. We went a bit too fast in the middle of the race. We were hoping the green line would be a little bit more like the blue line. Obviously, we went too fast. And then finally, this caused a slower finish, where we didn't have an end spurt. So with that technology, very simple technology, we can say that gave us some information that helped our athletes. And they admitted that it helped them prepare for that competition. But we want to be careful about that saying it's always been done this way. You've probably heard it a long time, but in these 2 tables here, what we see is the organization or organizers' results in the bottom. They give us 4 250 meter splits. That is very low resolution information. A lot can happen within the 250 meters. If we look at this more from a 100 samples per second type of feedback, we can see down here in the bottom that there's a lot other things happening within a race. This is the velocity over distance, and the 2 lines in this case are winners, so in the dark solid line, versus the bottom 3 athletes within a race. So their waveforms can change quite a bit, but based on this data, we can also look at it more deeply using other analytics and other sorts of modeling tools to see that using principal component analysis, we showed that the middle of the race is a very important time for these athletes. The bottom 3 athletes go way too fast in the middle, they don't have an end spurt, and therefore they lose the race. So I know this could be somewhat advanced. Without technology, we'll never get to this point unless we have we started using that. So finally, we get into this reliability and validity side of things. We are in the wearables era. We've been in it for a few years now, but there's new technology every day. You need to be very careful with the technology. There's information that comes out that it may look true, but it's maybe not true. It may not be valid. And you got to also be careful in the sense that there are so much data out there right now that you need to be looking at the information and try to look for the signal versus the noise. What actually matters, this goes back to that performance parameter comment I made earlier. We need to find what matters the most and get rid of all the other noise. Again, we need to look at the reliability. So is the measurement reproducible over time? So if you're starting really basic, you can test this over a long period of time. We want to know if this is actually collecting the right data over and over. And then finally, is the device valid? So does this measurement that you're collecting agree with the true value, also known as the gold standard? So I'll quickly go through an example of this in canoeing again. We look at, again, stroke rate and velocities throughout a training piece or in a race. And in this case here, we wanted to look at something called a speed coach in rowing. It's often used, the Nelson Kellerman versus the spin unit. And we want to look at that as the gold standard because it has a higher sampling rate. What we find here is that these 2 waveforms are stroke rate over time. So in orange, you see that's the speed coach. I call that the challenger, versus blue. That's the spin unit. That's the gold standard. If you look at that from a coach's perspective and an analyst perspective, I say that's not good enough. If you're going to give one of these devices to an athlete, we need to make sure there's no 10 strokes per minute swing in these things because this affects their performance on a day-to-day basis. However, if we look at that maybe we can change the sampling rate of the accelerometer to help us get better. But at the end of the day, if you just pick this off the shelf, you need to be careful of this stuff. On the other hand, if we look at it from a velocity perspective, velocity over time, this is measured through GPS and likely some sort of integration with velocity from the accelerometer. This is better. This is actually quite similar. So as a coach, I would be more inclined to give that speed coach to an athlete to measure velocity versus stroke rate. It's important to note here is just one case. This isn't a scientific study or anything like that. So, I mean, Nelson Kellerman maybe has data that shows that it's more accurate. So take that with a grain of salt, but it does show in that specific situation that the stroke rate wasn't good enough. And then finally, these are my last couple slides here. If you're interested in this sort of stuff, as I mentioned before, technology is becoming cheaper and cheaper every day. Like I said before, you could buy sensors for $2,000-$3,000 at one point. Now we can buy them for like $100. You can get a movement sensor with heart rate capabilities, ECG capabilities, accelerometer, gyroscope, you name it, all of the bells and whistles. And you can get this really cheap. So this is an example of a MoveSense by Sunto. I have one right here. If you look into your screen, it's very small, about as big as my watch right here. And it also has on the back here 2 little prongs that can measure heart rate. So we can put that on a strap. We can measure various metrics with our athletes while also including heart rate. So most athletes, especially in endurance type cyclical sports, already have a heart rate monitor on. So this is another way we can collect those data and make it more meaningful. So if I'm going to try something here. I'm going to try to hook up my iPad just so you guys can see a quick demonstration. I'm going to share the screen, so bear with me. Just to give you an idea of how this works. Hopefully my iPad will pop up with shared. So what we can see here is if we go into the MoveSense app, again, I have this sensor here. If I move it, what we can see is in real time, the gyroscope. So if you remember back to what I mentioned, that was angular rotation. So as I rotate the sensor, it can give me information. This could be really important for, say, a gymnast or a speed skating coach or a figure skating coach when they're twirling, that sort of thing. So again, you can use this information if you give an athlete a cue. Maybe this is a way that you can get this information in real time to say, hey, this isn't working, let's try this. Again, this is extremely simple to use. I'd be willing to even chat with you about it, but out of the box, you download it onto an iPad, the app, and it works within seconds. Very, very simple to use. And then we can also do, we can do accelerations, that sort of thing, but I think you guys get the point from that. Let's see if I can stop sharing here. All right. So finally, just to conclude, I just want to say the time to start this, I feel, is now. We've already identified that trends in technology use is increasing. So now that we may have a little bit of time on our hands, this could be a time to investigate how technology could be used in your sport. And again, if it isn't being used or you're getting stuck on ways to incorporate it, you could always look at the literature and see what else has been done out there, or YouTube. There's tons of stuff on YouTube. Again, keep it simple. There's nothing worse than showing up to practice and the analyst or the coach is fiddling around with technology and it's not working, and the athletes are getting frustrated, it's hot, whatever, it's 6:30 in the morning. Just make it simple. Make it as simple as you possibly can make it. And then start from there. Get them to buy into it, show them how it helps, and then progress from there. Again, collect only what's important for performance. So let's start slow. Let's determine what that performance metric is and how it's going to help, and start there. We want to track metrics over time and relate this information to performance. So it's really not that helpful to just collect it one day and then forget about it. Try to make a constant, maybe 1 to 2, 3 times a week data collection schedule, so that you're giving information to the athletes quickly. Give them feedback. There's nothing worse for them in their perspective. I've dealt with this from experiences. If they turn into kind of like robots, you just continuously collect data from them and don't actually give them any information back. That can be a recipe for disaster. Athletes won't try as hard and that sort of thing. And I actually don't blame them. I'm not talking about this from looking down on the athletes saying you have to do this, but I do think if you work collaboratively with the athlete, technology can really help. And then finally, make sure that technology is valid. Again, there's nothing worse than collecting a ton of data just to find out that it's not actually measuring what you think it is measuring. So that is my spiel. Thank you very much for listening. I don't know, Kirsty, if we have time for questions, or if there are questions that you have.
Yeah, for sure. Yeah, if anyone has any questions, feel free to speak up now or write them in the chat box. All right.
Okay.
Yeah. Well, thank you so much, Josh. Yeah, I think this is great. And I like what you said about like how like now's time to start. Like some coaches have a lot of free time right now. I know me personally, like I do a lot of like video and written stats, but I've never used technology besides video. So this will be a time that I can start exploring that. So thank you for all this information. Coaches, if you have any questions, feel free to speak up now. But if not, we will be continuing these sessions next week. So we have 3 lined up for next week, starting on Tuesday. And then we'll have another 4 the following week after that. So definitely keep an eye out for our sessions. And we will be posting all of these on YouTube. So definitely check out our YouTube page. And thank you so much for joining us today. And hopefully we'll see you next week. Thanks, Josh.
Yeah, thank you.